In this video, we're going to look at what's called the inverse of a function. So if we remember, we said a function is used to perform a series of operations. So we've been using x as what we called the input into the function, and we put x into the function where we perform a series of operations, and then that function is going to produce for us a y value, which we've also called output. The inverse of a function is just basically reversing my original function. So if the function f applied an input x, it's going to give us some result which we called y. So applying the inverse, so we'll call that g, means that what I'm going to do is I'm going to take that y value and put it into the function, and I'm going to get back the same x value that I originally started off with. So let's see how we represent that inverse of a function. If I'm writing in function notation y equals f at x, then the inverse of a function, it looks like what has an exponent of a -1. This is our notation for y equals the inverse of f. It's not a -1, it's used to indicate inverse. This may make a little more sense with an example. So if I give you the function f at x and it has a set of 3 coordinates. Okay. Since the inverse reverses the function, it means that the x values basically become y values, and vice versa, the y values will become x values. So essentially what we're doing is we're taking the input and it's going to become output, and the output would then become input. Okay, so we're going to switch. We're going to switch input for output and vice versa. By doing that, all that means is then I'm going to write the inverse of f as 2 and -3, 1 and 0, -4 and +5, which we see is the opposite of my original function f, where x was -3 and y was 2 in the first point, and we've switched it so that now my x value is 2 and my y value is -3. And we've done that for all 3 points. And that's basically how we calculate an inverse. We're going to switch the x and y values. Let's look at another example. So basically we said that the inverse is going to take the domain of my original function and change it into what we called the range of the function, and then the opposite, the range of the function is now going to become the domain. So if I give you an equation, this is a linear equation, f at x equals 2 minus 5x. What I want to do is I want to calculate an inverse. So again, we know that this function is going to get switched. So we were looking at input versus output, so let's change this function. Instead of writing it as f at x, we're going to let y equal 2 minus 5x. We said that function notation is just a way of naming our function. I'm going to change that back into the variable y. Okay? And the reason that we want to do that is we said we wanted to switch the domain of the function into the range and vice versa, so we're switching the x and y values. So we're going to do exactly that. We're going to switch the x and y values. So instead of having y equals 2 minus 5x, now I have x equals 2 minus 5y. Okay? So as an equation, we want to rearrange this equation now so that we can solve for y and determine what the actual new function is going to be. I want to be able to write this as an inverse function or possible relation depending on what we end up with. And so we want to be able to rearrange this equation for y. So taking my original equation, if I want to rearrange it for y, the first thing we're going to do is we're going to take that +2 constant and put it onto the left side of the equation. So now I'm going to have x minus 2 equals -5y, right? And then that -5 in front of the y has to get moved onto the left side of the equation as well. So we're going to divide both sides by -5. And if I reduce both of those equations, or both of the fractions, that means that we're going to end up with x minus 2 all divided by -5. Right? So this is our new equation for our inverse. So we're going to use our inverse notation that we talked about earlier, and I'm going to replace the y value now. And I'm going to write this as f inverse of x as x minus 2 all divided by 5, or I can split up the fraction into a common denominator and make it into 2 fractions. So I have that the inverse of x is -1 over 5x plus +2 over 5, because the 2 negatives will now become positive, which is exactly the same thing. It's just a different way of writing the same inverse function.